This is a video about using x to represent numbers and making simple algebraic expressions. We often use x and other letters to represent values either that we know or we don't know yet to form simple algebraic expressions. When we do this, we tend to use letters from the end of the alphabet like x, y and z or t to represent variables, things that can change, and letters from the beginning of the alphabet, A, B, C, to represent constants, things that aren't going to change very much. This isn't a hard and fast rule. A, B and C can be variables, X, Y and Z can be constants, but typically that's the way around we do it, certainly sort of with the early, easier sorts of algebra that we might try to do. Once we've done this, we've gotten used to it, we can perform arithmetic and do various shorthands, use various shorthands to make things simpler to see. So probably the most common shorthand is the index or power. So if we've got to write something like x times x times x, we would probably write that as x cubed. That's 3 x's in a row, all multiplied together, we'd write x cubed. If we were going to write something like 4 times x times y, we wouldn't write these time signs here, we just write 4xy, like that. We often collect like terms. So if we've got 5x plus 8x, that's the same as 13x. If we've got 4x squared y plus 7x squared y, well, that's 11x squared y. We would call this collecting like terms. These things are the same type of algebraic object, so we can put them together. Lastly, we might say if we've got 2 times x times x times 3 times y times x, we can kind of bring all of these pieces together into one place. So I've got 2 times 3 is 6, and I've got an x times another x, which is x cubed, and I've got a y in there as well. So I'll call that, the simplest way to write that thing is, I'll make that 3 a bit clearer, is 6x cubed times y, 6x cubed y. One of the beauties of these algebraic things is that it doesn't matter what order you do multiplication in. So if I think about this one again for a minute, I'll write it back up. It's worth noting that 4x squared y is the same as 4yx squared. And the same thing, because it doesn't matter what order you do multiplication in, right? So 2 times 3 is the same as 3 times 2. Everybody would be happy with that idea, I hope. So the fact that I've got the x squared and the y and the x squared the other way around here doesn't matter, they're the same thing. So if we had 4yx squared plus 7x squared y, I can think of this as being the same. I can say, well, that's equal to 4x squared y plus 7x squared y, and that's just 11x squared y. It's one simplification, an easy trick. One more thing to tell you to make sure that you're really clear on is that 3x squared, as an example, this means 3 times x squared, and the squared is only acting on the x. This is x squared, and the 3 doesn't get squared. It's different to 3x squared means 3x times 3x. 3x times 3x is 3 times 3, which is 9, x squared. So when there's a bracket around it with the squared outside the bracket, you have to square everything in the bracket. You have to square the 3 and the x. When it's just like this, you're only squaring the thing that the power is immediately next to. So this is 3x squared. It's 3 lots of x squared. It's not 3x squared. Okay? So these two things are different. Be careful. The last thing to say in this little video is that if you've got an algebraic expression and you're given values for the variables or constants in that algebraic expression, you can evaluate it. So if we're told that t equals 4a minus 3x squared, we can find t when a equals 12 and x equals 2. We do this just by putting these numbers into this expression. So t will be 4a just means 4 times a, and in this case a is 12. And then we've got to subtract 3x squared, so we've got to do 3 times 2 squared. And one important thing to remember when you're dealing with these is that that's one term, this is another term, and I can work those out separately. So 4 times 12 is 48, 3 times 2 squared, and I'll do this over here quickly, it's just 3 times 2 squared, it's 3 times 4, which is 12. So I've got 48 minus 12. So that is going to be 36. Okay. Two separate terms, evaluate them separately, and then subtract them from one another. Just to make sure, we'll do one more example. I'll take this out. So we could do something like evaluate, or find the value of, 6t squared minus 2a plus x when t equals 3, a equals 5, and x equals 1. And to do that, we're just going to put those values in. So we've got 6t squared minus 2a plus x. So we're going to take 6t squared and t equals 3. So we've got 6 times 3 squared. Minus 2a, so we've got minus 2 times 5. Plus x is plus 1. And then I'm going to treat these as 3 separate terms, one after the other. So I'm thinking, what is 3 squared? It's 9. I can do my minus 10 plus 1, because 2 times 5 is 10, and plus 1 is that. 6 nines are 54, minus 10 plus 1. So 44 plus 1 is 45. So there you go, simple little video on simple algebraic expressions and evaluating them when you know the numbers.